could be called the output. So set A is the input and set B is the output. So when we're dealing with functions, we could say this, that every input has exactly one output. Oh, maybe I should have left that up there, like that. Okay. So when dealing with functions, every input has exactly one output. Here's another example. So I'm going to try to determine if this is a function. And let me write the directions right above that. So I'll write them where I have example. Is this a function? Here's a rule. I liked a lot of books, if you look at the definition of function, they'll say a rule that meets a certain condition. So add 5 to the number I pick. Now, a few years ago, I was doing this. It was a regular algebra class. We were covering functions. And because I called something a rule, one of the students in the class thought, oh, that's very important. I need to know all those rules she's writing down. No, it's just an example. The definition of function in some books says a rule that gives some sort of assignment. From something from one set of objects to something from another set of objects. So just because I called it a rule doesn't mean like that's some hard and fast math rule that you need to know. It's just something I'll use. Here's I get to pick the numbers and you follow the rule. So if I say 4, then you will say 9. Could you give any other answer by following that rule? No. Now, just because I was able to do it for one number and I got one answer, doesn't necessarily mean that it's a function yet. I got to look at several, and then even then I might be sort of like, it's like those patterns. You see a pattern and it might or might not work. Here, but I'll pick a few more. -2 and follow this rule. Get 3. If I pick 0, 5. And if I pick -5, I got 0. And I'll pick one more. 3 gives me 8. Oh, we might pick more than that. It looks like it's a function. I'm going to circle the inputs like this and circle my outputs. And maybe I should have drawn my arrow a little closer, but I didn't. So I have this little picture. Here's the inputs, here's the outputs. I pick a number, I follow the rule, I get an output. if I picked a generic number like n or x, what's the output? X plus 5. And so we might want to take a look and see, you know, for every x, for every number I plug in, do I get only one correct answer following this rule? I think so. This little picture here, well, it's called a picture. This is a picture of this function. And in the upper level math classes, they'll call this a mapping. So this, but make a note of this, because if I ask this on the next test, it gets real confusing and students are not quite sure what I'm asking for. So this is a picture of this rule of add 5 to a number. And sometimes you'll hear people call it a mapping. It can also, the picture that is, it can also be called a mapping. Yeah, on the second test, if I ask for a picture, students in the past have gotten pretty creative with, you know, trying to figure out exactly what that means, because I didn't stress it enough in class.